Good afternoon, everybody.
Good afternoon.
Good afternoon.
Good afternoon, ma'am.
Afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon.
Good afternoon, ma'am.
Good afternoon. So last time we had done up to I think binary search we were doing in divide and conquer. We had done binary search, right? So today we will be talking about sorting algorithms, right? So again, we are talking about the divide and conquer algorithms. So in sorting algorithms, we'll again talk about how we had to sort arrangement of list or something in ascending or descending order, whatever order it may be, right? By following the divide and conquer rule, right? So generally there are number of sorting algorithms like bubble sort, merge sort, radix sort, quick sort, and many more. So in this section we will cover merge sort and quick sort algorithms based on the divide and conquer approach, right? So we'll be talking about that. The first algorithm they are talking about is merge sort. So merge sort algorithm is a divide and conquer based sorting algorithm. It follows a divide and conquer approach to perform sorting. This algorithm divides step in divide step repeatedly partitions an array into several subarrays until each subarray consists of a single element. So what you are doing is in this algorithm you will keep on dividing your array or the list, right, into subarrays, right, until you have single element there, and then it merges sub problem solutions together according to following steps. So now then you have to merge it according to your ascending or descending order. In whichever order you are sorting it, you have to merge it, and that will be your solution later on. So what you have to do, first you divide it. So divide the array into two equal sub arrays, compare the sub arrays first elements, right? Then conquer, solve each subarray by performing sorting operation. So conquer means you have to sort it according to whatever operation, ascending or descending, you are doing. Apply the recursion unless the array is sufficiently small. So you should apply recursion. If it is sufficiently small, then it is not required, right? So apply recursion unless the array is sufficiently small, and combine merge the solution into a single array. Then you will merge it, right, into a single array. So they've given you an example. So they are saying the following example illustrate the above steps. Suppose you have the array with the following numbers: 37, 20, 23, 30, 18, 15, 27, 17. This is your array, and you have to sort it. In divide step, the array is divided into two subarrays. So they have divided like this. Up to 30 is first part, 18 to 17 is the second part. So these are the two arrays you have divided, subarrays. In the conquer step, we sort each subarray. So you will sort this array. So 20 from smaller to that is ascending order you are sorting. So 20, 23, 30, 37 you have sorted the first array. Then this will be sorted. 15, 17, 18, 27 is sorted. So both the arrays are sorted in some order. Now you have to combine or merge all the subarrays are merged in sorted order. So if you see this one, so 15, 17, 18 comes here, then 20, 23, 27 will come, then 30, 37. So this way they have merged it, right? Basically this is what they are doing. We'll go through the explanation also how they are doing it. So they are just telling you that the algorithm merge sort, where you are passing x as the array, m and n you are passing, right? So if m is less than n, so I is equal to m plus n divided by 2. So m and n are your you can say the index numbers. The first and the last index, m and n will be following. The first index will be 0 and the last index whatever the index value will be. So if your this index is less than the larger index n, right, m is less than n, so find out the middle index. So m plus n divided by 2 you will do. So you are finding the middle index I, right? So now you have to sort your arrays into two parts. So wherever your I is there, so the first array will be merge sort xmi. That means first index to ith index will be your first array x, right? And then the second array which you are doing is merge sort x I plus 1 n. So the next array will be from I plus 1, that means this one, to n will be your second array. So these are the two arrays you have divided. So first is up to the midpoint I. First will be from the starting index to the midpoint I, and the second will be from midpoint I plus 1 to n, the last index, right? These are the two arrays you have divided. Now you have to combine them. You will sort them first, right? You will sort this, then you will combine it, merge it. So you are combining x m I n. That means the the least index, the middle index, and the last index, all everything is combined here, right? All else you will say it is already sorted. So they have just given you a rough idea of how they are doing it. So they are telling you that you have to merge two sorted arrays s1 and s2 into one sorted array s. So you are dividing two arrays. Suppose you are dividing your arrays into S1 subarray and S2 subarray, and then you will merge it into an S array. That is what they are doing. So here again they are telling you that you merge S1, S2, SMN. So this is your final array they are talking about. This is your subarrays, right? And m and n are the 0th index and the last index. So int I, j, k, they are defining three integers. I is equal to 1, j is equal to 1, k is equal to 1. All three of them they have initialized to 1. While I is less than equal to m and j is less than equal to n. So if I is less than equal to m, the lowest index, and j is less than equal to n, the highest index. So you have to scan if s1I is less than s2j. So they are saying if s1I, the first index, is less than s2j, the second index, right? So sk is equal to s1I. So you are putting another variable for index, right? In that you are putting s1I, because s1I is the smaller index, right? Then you are incrementing I, right? So that is there if s1 is less than s2. If s1 is not less than s2, then sk is equal to s2j. That means this one is smaller, so you are putting in sk s2j, and you are incrementing j plus plus, right? So if it is this smaller, then this will happen. If this is smaller, then this will happen. And then you will also do k plus plus, right? So that is happening. And then again your while will keep on running, and it will keep on comparing these values. Whichever is smaller, it will keep on adding it in the final array s. So that is how it is working. And if I is greater than m, if your I is greater than m, then copy sj through sn to sk through m plus n. And if matlab, in the loop only, if your I is greater than m, then you have to copy sj through s to n. That means second index values of the second array has to be copied to sk through sm plus n. Else, if I is not greater than m, then s1 will be copied to sm to sk through sm plus n. So this is what they have given you a merge algorithm, or you can say the pseudo code of how it is doing. And for example, they are telling you this: consider an array A of size 4, 98, 23, 45, 14. These are the values. Perform merge sort on A. So on the array A, we have to merge sort that. Merge sort follows partitioning of an array into two subarrays from the middle index. So this partition is performed recursively on each subarray till individual elements are obtained. Then merge operation is performed on individual elements in a sorted order recursively. Following are the steps of merge sort to sort array A. So the red circle denotes the considered elements at a particular step. So first, your array is this one, which is highlighted by the red. So 98, 23, 45, 14, these are the arrays. So your starting index M is 0 and the last index will be n is equal to 3. If you start with the index 0, 0, 1, 2, 3, 4 elements are there. So 0, 1, third is 3 is the last n. So last index n is 3 and starting index is 0. As m is less than n, so your 0 is less than 3, yes. If condition is true, so calculate mid. So what is the mid? 0 plus 3, that is m plus n divided by 2. So 0 plus 3 divided by 2, which is equal to 1. So 0, 1. So this is your middle element, I, you can say, right? So recursively called to merge sort A01. So your first array will be array A will be starting index will be 0 and last index will be 1, which you have found out the middle point. So 98 and 23 will be the first in array and the second array will be 45, 14, right? So now again so 98, 23 will be your first. So m again your index m is 0 and n is 1. So you have divided your into this. Now again you are seeing m is equal to 0 in the this first index. M is equal to 0, n is equal to 1, the last index is 1. This for this array, for the first part of the array we are talking about. As m is less than n, again condition is true, again we'll find the midpoint. 0 plus 1 divided by 2, so 1 divided by 2 will be 0. So our sorted array now becomes A00. So that means 98 only from this, the first part. Right. Now M00 and N00, as M is not less than N, because here again your array is already sorted, single element has reached, right? So it is false. So the complete this complete recursive call of merge sort A00. Now recursive call to merge sort A11. So now this 23 is left. So this has already been single element. Now 23 is left. So A11, right? So again we are saying m is equal to 1, the lowest index is 1, the higher index is 1, right? Now we'll compare it whether m is less than n. So it is not less than n. So again this has also been sorted, so single element has reached here. Now call merge A001, right? So we are now merging it. Now this has been fully this part, the first part of the array which we have divided, the first part has come to single element. Now we have to merge it. So A001, right? So A001 we have to merge it. Now we have to see in the merge process, each value in the two arrays are compared individually. Now you compare both of them, that 23 is less or 98 is less. So then they are sorted in the sorted order in a new array. As there are single values in the two arrays, both values are compared and stored accordingly in a new array termed as x. So suppose a new array is there, so we will the x is the array. Now we will check whether 98 is greater than 23. So 23 is replaced first in x, while 98 is placed after 23 in x. So in the new array, you will place 23 here and 98 here. First you will place 23, then you will place 98 in the new array. So this completes call of merge A001. So you have merged the two ones into one array X. Now recursively call to merge A23. So now the second part of your this 2 and 3 elements are the second part of your division which you have done. The second division we have not gone through. The second part is A23, right? The second index and the third index is the last one. So we are taking that part. So this part we are taking. Now your lowest index m is 2, n is 3, right? So you will compare m is less than n, yes, 2 is less than 3. So again we'll find out the middle index, that is 2 plus 3 divided by 2 plus 3 divided by 2. So that will be 5 divided by 2 will be 2, right? So that means this is a index. So A22 will be the division. So A22 we will so m is equal to middle index is starting index is also 2, last index is also 2. So that is there. So as m is not less than n, so this completes our array. So this single element we had come out, so it becomes this. Now recursively we will call m33, which is A33, which is left here, right? So m is 3, n is 3, which is not m is not less than 3. So again our single element which we have found according to that is this. Now we have to merge them. Now we will merge A223. So we will merge them. So in merge, each value in the two arrays are compared individually. Then they are stored in sorted order in a new array. So as there are single values in two arrays, both values are compared and stored accordingly in the new array termed as x. So now again you will compare 45 is greater than 14. So 45 will be placed first and 14 will be placed first and 45 will be placed later on. So 14 here, 45 here. So this completes your merging, right? So now call merge A013, right? So this one you are calling first, right? So in merge, each value in the now your so in merge, each value in the two arrays are compared individually. Then they are stored in sorted order in a new array. So in case of multiple values in any two arrays, each value of the two arrays are considered one by one and compared to stored in a new array termed as s accordingly. So as 23 is greater than 14, so now these two arrays are compared, right? Which you have found out, right? Which you have divided and found out. These two arrays are compared. Now 23 is compared with the first element of the first array is compared with the first element of the second array. So 23 is compared with 14. So because 14 is smaller, so it comes here and 23 goes here. So the value 23 will be placed after 14 in X, but will be compared with next value in the other array, right? So as 23 is less than 45, 23 is placed after 14 in X. The value 45 will not be placed after 23 in X, but will be compared with the next value in the other array. So now in your array, first 14 comes here, right? Now 23 is compared with the next value. 14 comes first in the new array. 14 is coming first, and then 23 is compared with 45 because 23 is smaller than 45. So 23 comes next in the array in X, right? Then as now 98 and 45 are left. So as 45 is less than 98, 45 is placed after 23. So 45 will be placed after 23 in X. The value 98 will not be placed after 45 in X, but will be compared with the next value in the array. So to compare 98, there is no other element in the array. So the next value to be placed after 45 is 98. So finally the sorted array is 14, 23, 45, 98. So this way merge sort algorithm works, right? So you divide the array into two parts by finding the middle element. Keep on dividing it by finding the middle element, right? And first you divide into two parts. So first you keep on dividing the sub array until you find a single element. Then again the second part also you keep on dividing and find the single element and then merge it, right? Keep merge it so that you find the sorted array in the sub arrays, right? Then you have to merge it finally, right? So you will get two arrays again. Then the two arrays individually you will compare the elements accordingly. Individually you are comparing the elements and putting it in the new array, right? um, Again you are comparing that which one is smaller for ascending order, and finally you will get your sorted array. This is the crux of the algorithm. So the analysis says that for simplicity, assume that n is a power of 2. Each divide step yields two sub-problems. So both of size exactly n by 2. So base count occurs when n is equal to 1. So when n is greater than equal to 2, then basically this algorithms give you, you can say, the recurrence relations give you that the complexity is O n log n. This is the complexity of a merge sort algorithm, right? So merge sort is not in place algorithm. However, it is an outplace algorithm as it needs O n extra space to perform merge operation. It is not suitable for array of small size. It is a stable algorithm, which means that the order of repeated elements in the given is not changed in the sorted array. So this is what merge sort is. Now they are talking about quicksort. Now in quicksort is another sorting algorithm that works on the principle of divide and conquer approach. It works by arranging the elements in an array by identifying their correct place or index. Moreover, it sorts elements within the list without requiring any additional space as compared to merge sort. Because merge sort, you are dividing the sub-array, then putting it into a new array, so you require extra space in merge sort. But in quicksort, you do not require any additional space, right? So due to which quicksort provides advantage of performing in-place sorting. In place means that you do not require any additional space, but merge sort requires an additional space. That's why it is an outplace algorithm, because it requires extra space. The arrangement of elements in the input array, which is to be sorted, affects the running time of the quicksort. So how you arrange the elements in the input array, how they are sorted, that affects the running time of the quicksort. So generally, it is the fastest among all sorting algorithm in practice, and that's why it is named as quicksort. The running time of quicksort is O n log n in average scenario. However, if the elements are sorted already, then it is the worst case scenario for quicksort, and its running time is O n square. So quicksort algorithm is different from merge sort algorithm. In quicksort, the array is partitioned around the pivot value. So you have to find a pivot value, and according to that, you will sort your algorithm in quicksort. Smaller elements than the pivot value are placed at the left side. So smaller elements, you will take a number as a pivot value from the list of array. From the list, you will take a particular number as a pivot, and that pivot value, the elements which are smaller than the pivot will be put at the left side of the array, and larger elements will be put at the right side of the array. This is a best case scenario. Right, this is the central idea of partitioning algorithm. So quicksort algorithm performs the following step. First, divide. So in this, an element of the given array is considered as pivot element whose correct index q in the array is determined by rearranging the array elements. So you will first find a particular number element. You will select a particular element as pivot, and its correct index will be determined. How you will find out the correct index of that element is when you arrange according to the this rule, that the elements which are smaller will be placed left and which are larger will be placed right of the pivot. So you will arrange them. Then the given array a m to n. So m is the 0th index and n is the larger index which is there, is partitioned into two subarrays a p2q and a q plus 1 to r in such a way that all the elements in a p2q are smaller than aq, right? And all the elements in aq plus 1 to r are greater than aq. So this is your pivot element, whatever your pivot element index q is, right? So you will arrange your array accordingly. You will divide the array like this, that the smaller elements will be this a p2q, smaller elements will be here, and the larger elements from the index where what the element index will be q plus 1 to r. You will arrange according to that, right? Generally, the procedure which is used to perform this step is termed as partition. The output of this procedure is the index q, which divides a given array A. Now conquer. After you have divided your array according to the pivot, you have to conquer it. The partition subarrays A P2Q and A Q plus 1 to R recursively call the step 1 to perform sorting of the elements. So you will recursively call this. Again, you will divide it to perform the sorting of the elements. Then you will combine, as all the elements are sorted in their respective places. There is no need to perform combine step, and the array is already sorted. So in this divide and conquer will already sort the array in a form that you do not need to combine the array. So it is already sorted. So the basic concept behind quicksort is, suppose we have an unsorted data a p to r to sort. Here partition procedure always select a element, last element ar. So generally we will select the last element of our array as the pivot element, right? And set the position of this AR as given below. So we will set this AR, the index number R will be the pivot, the last element will be the pivot. So now we will sort according to this. So A1, A2, AQ, Q minus 1, and AQ. AQQ is the pivot element. So this, whatever be the pivot element, whatever value is there, according to that you will decide. The smaller elements will be on the left side and the larger elements will be on the right side. So this is the way you will divide according to this. So A1 to Q minus 1 and AQ plus 1 to AN. You have divided it accordingly, according to your pivot. Now the two subarrays, AP to Q minus 1 and AQ plus 1 to R, is further divided by recursively call to quicksort, and the process is repeated till we are left with only one element in each subarray. Again, you will divide. Now this part will be divided, right? So again, you are dividing it. Again you will take the last element as the pivot, this one, and you will again divide it according to the pivot, the smaller elements at the right and the larger elements at the smaller elements at the left, larger elements at the right. Same way you will divide this also, right? You keep on dividing until you find single elements at the end, single elements at the end, right? Now your elements will, when you see the whole array, the sorted array will be the full array, because it is already sorted in a, you do not need to combine it, it is already sorted in a sorted form you have received. So that is what is there. So here they have given you an algorithm, quick sort. A is the array, P and R. P is the zeroth index, and R is the last index which is there. If P is less than R, Q is equal to partition APR. So you are dividing. So you are dividing quick sort APQ, then quick sort A Q plus 1 to R. So this is, you have divided your array into two parts, right? So this you have to do, and when P is less than R. So to sort an array A with n elements, initial call to quicksort in quicksort A1n will be there. Quicksort APR uses a procedure partition, which always select a last element AR and set this AR as pivot element at some index, say Q, in the array P2R. The partition will always return some index or value, say Q, where the array P2R partitioned into two subarrays, A P2Q minus R and A Q plus 1 to R, such that A PQ minus 1 is less than equal to AQ, and AQ is less than equal to AQ plus 1 to R. So these are the higher elements, these are the smaller elements. You partitioned it accordingly. That is what they are doing. So partition APR, Q is AR, that is the last element you have selected as the your pivot, right? I is equal to P minus 1. I is the pointing one position before P, that is uh, your index or whatever you can say, right? P minus 1, I is equal to P minus 1. For J, to p to r minus 1 do. So they are saying you have to for j is equal to p to r minus 1 do if aj is less than equal to r ar. If aj is less than equal to ar, I is equal to I plus 1, exchange ai aj. So here you are exchanging the, if you are finding that aj is less than ar, so you, what you are doing is you are incrementing I and you are putting ai. In ai, in place of ai you are putting aj if it is less. So that is what they are doing in place here, right? P minus, exchange a I plus 1 and AR, return I plus 1. So we'll see how this algorithm is working, how it is working with the, so the running time of partition procedure is theta, and since for an array a p to r, the loop at line 3 is running on time and other lines of code take constant time o1, so overall is on. So that is why they are saying this partition algorithm takes this, but the full algorithm takes O n log n time. Average time scenario is this. Average scenario of this algorithm is this. So let us see with an example. So suppose you have an array A of size 8 elements are there, 2, 8, 7, 1, 3, 5, 6, 4. These are the elements in the array, right? So we have to sort this according to quicksort. Now we have considered four temporary variables I, P, J, and R. These are the four temporary variables to perform quicksort. R represents the chosen pivot element. So the last element generally you will choose as the pivot element. So your R will be this last element, which is 4. Last index, which is 4. The value of the index is 4. Right. And as quicksort partitions array into two subblocks, the elements of the first block are highlighted with the light shade, while elements of the second block are highlighted with dark shade. So the initial array of 8 elements and variable settings, none of the elements have been placed in either of the two partitions. Right now, no partition is there. Only the index P is this, your first index, and R is the last index, right? And I is generally p minus 1, right? So if you are starting with 0, so I will be minus 1 basically right now, and j will be equal to p only. They are saying j will be set to that. That is what they are saying. The value 2 is swapped with itself and put in the partition of smaller values, right? So here now your pivot element is R, that is last element 4. So P is so you have put your R is equal to, so R represents the chosen pivot. So R is your pivot. Now you are comparing the pivot value with the first element P. So value 2 is swapped with itself. The value 2 is swapped with itself because it is smaller value with r. So and put it in the partition of smaller values. So it is put here only at the left side of the 4, right? Now the values 8 and 7 are added to the partition of larger values, because if you compare 4 with 8 and 4 with 7, first you compare 4 with 8, so it is larger than 4, and then we compare 4 with 7, again it is larger than 4. So the values are have to be put on the right side of this pivot. So what you will do is the values uh, so what you will do is if you see here, uh, here your P is swapped with itself and 2 remains here only. Now your J comes to here. J is incremented and J comes here only to the next value of the array. And now 4 is compared with 8, right? So it is larger. We have not swapped right now. Then j comes to the next, it is incremented, j comes to the next value. Again 4 is compared with 7, it is again larger. So j is incremented, j comes to here. now, right? So next increment j comes here. So now what happens is 1 is smaller than 4. 1 is smaller than 4. So what it will do is it will swap 1 here in place of 8 and put uh, 8 here in place of 1. So 1 is put here and 8 put comes here, and j is j comes to the the decremented and come to the next index, which is this one 7. So now you're sorry uh, so now you are swapping this. Sorry, you have swapped 8 with this 1, and 1 comes here, 8 comes here, and the next index, which is j, is incremented, and the next so I is also getting incremented. You, if you see, j, I and j, the two variables, I was earlier minus 1. If if zeroth in p is zeroth index, so I will be minus 1, because 0 minus 1 will so I is minus 1, and j is 0th index only initially. So as when you are swapped, you are comparing with the pivot value, that p, the index this is swapped with itself, the j is getting incrementing, I is also getting incremented. So I becomes 0, j becomes 1. Right. So then you are again you are seeing I is here. Now you are seeing that a the next value you are comparing. So the next value is 7. So j comes to the next index, this which is 1. So now you see that it is smaller than 4. So you will swap this with this. So 1 is swapped here, and 8 comes here. So I is incremented again, and I becomes this one, and j becomes this one, is incremented to here. Right. So now the values 1 and 8 are swapped already, and the smaller partition is growing. Now the values 3 and 7 are now because 3 and 7, these are the values you are comparing now. So what you will, again, 3 is smaller than 4, and it is also you have to swap these values. So 3 comes here, because 3 is also smaller than 7. So 3 comes here, right? And 7 comes here, and I is incremented, it comes here, and j is incremented also, it goes here, right? So these are the two values you have compared. Now 5 is greater than 4. If you see, the pivot now is great. Now the pivot become, the values are greater than the pivot value, which is the last 4. So now these 213 is already smaller than this. So that is there. 875. We are seeing that 5 is also greater, then 4, and 6 is the next value also we compare. So 6 is also greater than 4. So 8, 7, 5, 6 from the pivot are greater. So now what will we do? These elements we start now. The larger partition grows to 5 and 6, and the loop terminates. So loop terminates here, right? So in line 7 to 8, right, uh, here, so what we will do, the loop terminates. What we are doing, we have swapped 4 to here, right? So in line 7 to 8, uh, the pivot element is swapped so that it lies between the partitions. So now what you will do, because your elements so here they are saying they have swapped here 8, 7, so 6, this they have swapped, but I'm not we are not swapping it. It should be 8, 7, 5, 6. It should be like that only, I think. And this pivot element you are shifting here now, right? So pivot comes here, and all other elements which are greater than the pivot element, it is on the right side of the. So in line 7 to 8, the pivot element is swapped so that it lies between the two partitions. So you have done that, right? So they have done it like this, but now again you have to partition it like that, that you have to swap it again. You have to compare the elements and swap it, so that 1 2 3 4 5 6 7 8, this way the elements are arranged, right? So inside this only, you do not require any extra space. Inside this array only you are doing changes in your array. So you will swap again, you will compare the right side elements. So you will compare the first two. So 1 is kept here, 2 is kept here, then 3 is greater than this, 4 is greater than this, so it is okay. Then 7 is compared with 5, 5 comes here, 7 comes here. Then say 7 is compared with 6, 6 comes here, 7 comes here. So now your final sorted array will be done. So that is there. So generally the best case is O n log n is the best case for partitioning sub array or balance. Worst case is O theta n square, right? Not n, it is not n2, it is n square. And average case, except best case or worst case, A to C shows the recursion depth of the best, worst, and average case. So they are just showing the recursion part of that. That is generally it is O theta n log n for the best case, and the worst case also they are showing. So this is the way they have shown you. It is generally this, right? So now they have also given you check progress questions also to sort the array in ascending order using merge sort. This is the array, right? What are the properties of merge sort, you they are asking you. And then third question is sort according to quick sort. Again, your last element will be your pivot, right? These are some of the questions. So generally go through the check progress questions, right? From them also sometimes not the same values will be there in your examination, but from them also you get an idea how the question may come in the question papers, right? Now another divide and conquer algorithm is apart. Now we are not talking about sorting algorithms. These are the two sorting algorithms they have talked about: merge sort and quick sort, right? Then we have another divide and conquer algorithm, which is known as integer multiplication. Now, the brute force algorithm for multiplying two large integer numbers, which every one of us uses by hand, takes quadratic time, that is O n square, because each digit of one number is multiplied by each digit in another number. So let us explore the better algorithm, which applies divide and conquer technique for integer multiplication for large numbers. So this algorithm is known as Karastuba algorithm or Karastuba method, which follows the divide and conquer approach, right? So assume x and y are two. So you know how we multiply by our hand two numbers if they are two. So one number is multiplied with the other. So it generally takes O n square time, right? So we have two n-digit numbers. Divide x and y into two halves of the approximately n by 2 digits each. So if you see this number, right? So we have to divide it into, suppose, two halves like this: 657 and 138. Like that we will divide, right? So this is they have given you an example. So let us generalize the number representation. They have done that. I'll show you some other procedure rather than going this way. Sorry. So suppose so step by step, suppose you have two numbers: x is equal to 1 2 3 4, y is equal to 5 6 7 8. These are the two numbers you have. Now you have to split each number in half. So generally let x is equal to a divided by c dot 10 to the power m plus b, and y is equal to c divided by c dot 10 to the power m plus d. So this is a formula they have given you, where m is the half the number of the digits. So suppose this number, if we divide it into 2, so a will be equal to 12, and B will be equal to 34. This number. A is 12, B is 34. We have divided this number into half. And the Y one is C is 56, D is 78. So this is also we have divided into two half. Now we have to compute it like this. This is a formula for computing X, and this is a Y, right? So AC, if we find out AC, A into C, so AC we are finding out. So A into C will be 12 times 56. That is 12 into 56 we are doing. So 12 into 56. The first part of X and the second part of Y, A and C we are multiplying. So it is 12 into 56 is 672. Then B into D we will do 34 into 78. 34 into 78 is 2652. We have done that. We have computed this. Now we compute A plus B into C plus D. So A plus B into C plus D. Yani 12 plus 34 multiplied by 56 plus 78. This we have done. So we get 12 plus 34 is 46 and 56 plus 78 is 134. So 46 multiplied by 134 is 6164. So these three things we found out. Route. Now compute the middle term. So we have to find out, first we'll find out the compute the three products. So we have found out A into C, B into D. Then we found out A plus B into C plus D. These are the three things we have found out. Now compute the middle term. So how would we compute the middle term? A plus D plus B plus C. A into D plus B into C. So these are the cross multiplication you have done. A into D plus B into C. So A into D, if you do it, A into D plus B plus C. So what they have found out, the formula will be A plus B into C plus D minus AC minus BD. So this they have given you the middle term. This is the formula A plus B into C plus D minus AC minus BD. So your A plus B uh, into C plus D is this value 6164. This is the value you are getting for A plus B into C plus D. So your value is 6164 minus AC is 672 minus BD is 2652. So you will subtract these values and then you will get 2840. This is the middle term, right? Then combine the results. Final result is AC divided by C dot 10 to the power 2m plus A D plus BC divided by C dot 10 to the power plus m plus BD. That means 672 C dot 10 to the power 4 plus 2840 C dot 10 to the power 2 plus 2652. So this means that you have to AC is your AC is 672, right? 10 to the power 4 you have to take, because there are four digits. 10 to the power 4 plus 2840 10 to the power 2 you are taking, right? 10 to the power 2. So this is 672 into 10 to the power 4 will be four zeros, right? 10,000. So 672000 will be the value. Then AD plus BC 12 into 78. AD plus BC is this 2840. So 2840 into 10 to the power 2, that means 1000. So 2840 into 1000 is 284,000 plus BD. So BD is 2652. So these are the values you will add up, add three of them, you will get 7006652. This is the result. This is known as the Kastur split, the divide and conquer approach of Karstuba multiplication algorithm, or integer multiplication, you can say. So first, you have two numbers. You will divide it into two equal parts. So x will be divided 12 and 34. A will be 12, B is 34, and y will be divided again with two parts, 50 to this 56 and 78. You have divided that, and then you will find out according to this formula. You have to find out that you first compute the three products AC, right? BD you have found out, then you will find out A plus B into C plus D, right? So this is the values you will find out. These are the three computations you have found out. Then you will find out the middle term, AD plus BC, which is A plus B into C plus D minus AC minus BD. So you will find out the middle term also. Now you will combine the result in this formula, which is multiplied by 10 to the power AC divided by 10 to the power 2, right? Right, 10 to the power 2m. 2m will be the m is your, m is the half the number of digits. So 2 to the power 2 will be here 4. 2 to the power 2 is 4, because here your half is your total digits are 4, and half of that digits will be 2. So that's why 2m means 2 into 2, that is 4. 10 to the power 4 will be here. So 10 to the power 2, because m is 2, your half, so 10 to the power 2 will come here. So here it is 4, here it is 2. So in this formula, you have to put AC into 10 to the power 2m plus AD plus BC into 10 to the power 2, or m you can say, plus BD. So you will take the values from here and put it in the formula accordingly, and you will find out this. This is known as, so if you actually multiply with your hand, so it will give you this answer, right? This is what they are telling you. So generally, if you see this here also, they have 657 into 10 to the power 3 plus 138, 6578 into 10 to the power 3 plus 381. So something like that they have divided. So XL into 10 to the power m plus XR. So let us generalize the number representation. If Z is an n digit number, it would be divided into two halves. The first half with ceiling with n divided by 2, and the second half with floor n divided by 2, as shown below. Right, so Z1 will be XL into 10 to the power m plus XR. Z2 will be YL into 10 to the power m plus YR. Z1 into Z2 will be equal to XL into 10 to the power m plus XR, YL into 10 to the power m plus YR, which is equal to XL into YL into 10 to the power 2m plus XL into YR plus YL plus into XR to 10 to the power m plus XR YR. The same thing which we had done in the this part, the same thing they are talking about, right? So this is so they are saying, if we do these four multiplication recursively, applying the algorithm and terminating at the base condition, the recursive relation of will come out to be this, and applying master method, it is actually ON square, right? The complexity of this algorithm. So again, they are finding out with the master method the complexity. We are not going for that, right? So this is your Karstuba method. So understand the Karstuva method accordingly, or the integer multiplication, you can say. This is the integer multiplication method which I have shown you. This is one of the methods of divide and conquer. Then another is matrix multiplication. So matrix multiplication, a binary operation of multiplying two or more matrices one by one that are conformable for multiplication, comfortable you can say. For example, yeah, we do you know the rule for matrix multiplication? Everybody, what is matrix? Everybody knows. If your first matrix column should be equal to the second matrix row, yes or no, then it can be multiplied. So the, for example, two
Yes, ma'am.
matrices A and B having the dimension P into Q and S into T respectively would be conformable for A into B multiplication only if Q, which is the column of first matrix, and S, which is the row of second matrix, should be equal. If the column of first matrix is equal to the row of second matrix, then your multiplication is possible, right? And for B into A, if it had been B into A, then it would be T is equal to P, right? Just an example they are saying. So matrix multiplication is associative in the sense if A, B, and C are three matrices of order M into N into P, and P into Q. Now, why we are talking about matrix multiplication is we are not saying that you only have to multiply two matrices. Now, if we have to multiply three matrices, A, B, and C. So A is of order M into N, B is of order N into P, C is of order P into Q. Then the matrices A into B into C and A into B into C are defined as AB into C equal to A into BC, and the product is an M into Q matrix. So they are saying it will be M into Q matrix finally if we multiply the three matrices, whatever way we multiply, right? So matrix multiplication is associative, right? You can multiply first A into B into C, or you can multiply first B into C into A. Whatever way you multiply, it is associative. Both will be equal, and the order will of that product will be M into Q. M into Q. So matrix multiplication is not commutative. For example, two matrices A and B have dimensions M into N and N into P. Then if you are multiplying A into B, so your n and n will be equal, then they will be multiplied. But if you are multiplying B into A, they both will not be equal. B into A means P into M should be equal. So because BA is not comfortable for multiplication, even if A and B are comfortable, so this is not possible. This is not commutative. Matrix multiplication is not commutative. For three or more matrices, matrix multiplication is associative, yet the number of scalar multiplications may vary significantly depending upon how we pair the matrices and their product matrices to get the final product. Right. So they are just saying, if we are talking about the straightforward method, these are the two matrices A and B of order they have given you. 2 by 2 is the order of, so M is 2, N is 2. Right. So both the matrices can be multiplied because the column of first is equal to the row of second. So both are we can, square matrices are possible to multiply. There is no issue in that because row and column both are equal. So they are possible to multiply. So the Cij, the final product, will be equal to sigma I is equal to k is equal to 1 to n, right? Aik into bkj. So AIK into BKJ, we have done the multiplication they have given you. That means C is equal to C11, C12, C. It will also give you 2 by 2 matrix only after multiplication. And according to the in C, how you write that, for you have to use two uh, for loops for representing an array. All those who are from computer background must be knowing that you have to use nested for loop, two for loops. For I is equal to 0, I less than n, I plus plus. This is for the first array, and for sorry this is for the row, right? For the row you have to use this. How many rows are there? There are two rows, so n will be 2 here, right? And for int j is equal to 0, j less than n, j plus plus, this is for the column. So there are two columns, so again n will be 2 here, right? See, so initially we will be putting our the product array initially will be equal to 0. Cij, I is the row index and j is the column index. So ij will be equal to 0 for int. Now we have to take another third for multiplication. We have to take third for loop for k is equal to 0, k less than n, k plus plus. Again n will be 2 here, right? Cij will plus is equal to, that means Cij will be equal to Cij plus aik into bkj, right? Because one of the elements has to be arranged accordingly, so the formula is aik into bkj. So this will multiply the two matrices accordingly, right? Because how do we do multiply in this? We have to take the row of first and the column of second, right? And multiply. Yes. So according to that, this is what the formula will give you, right? So now this is normal algorithm and normal multiplication of matrices, how we multiply matrices. If we go by this, suppose I just write it here. So we are just taking one of the examples here. So the resulting matrix row of A into column of B, this we have to multiply. The rules they are giving you, sorry. Uh, and we have to sum the product. For example, they have not given you. So let us see in Python what they are giving us the result. So these are the two arrays now. So this is not a problem for them because they are using np dot ab. This would not be a proper implementation. We'll go for an image. I'm just showing you. So here, suppose you have these values 1, 2, 3. This is a row of first and this is a column of second. So how you will multiply is 1 into 10 plus 2 into 20 plus 3 into 30. So this will be your first value, right? So if you see here, this is a 2 by 2, 2 by 3 matrix, and this is a uh, this is also a 3 by 2 matrix. This is a 2 by 3, this is 3 by 2, because the column of first is equal to the row of second. So that's why it is possible to multiply. So first row of the first array and first column of the second array are multiplied. So 1 into 10 plus 2 into 20 plus 3 into 30. This will be the first element of the array. And your Matrix will be of what order? 2 by 3. 2 by 2, sorry. 2 by 2. Right? The index of row index of this and the column index of this, that will be your, so 2 by 2 will be the matrix. So now again this with second, so first row with the second column of the second array. So this will be 1 into 11, 2 in plus 2 into 21 plus 3 into 31. This will be the second element of the first row. Then the second row comes. So the second row you take of the first and first column of the second array. So 4 into 10 plus 5 into 20 plus 6 into 30. This will be the, in the next row, the first element. Then 4 into 11 plus 5 into 21 plus 6 into 31. This will be the second element of row 2. So this is the final result. Add it, and this is the final result. This is what you do. Right, this is your normal multiplication. And for C implementation, if you see, so if you see the C implementation of matrix multiplication, you can see whatever example you want to see. I'm just giving you an example. So this is, they have given you, so this is the first matrix they have taken, matrix ij, the first matrix they have taken, right? And okay, in one of the matrices they have put 2 by 3, in the second they have put 3 by 2. I will take some other example. So there are two matrices so there are two matrices M1 and M2 they are taking, right? Matrix 1 and matrix 2. And there is a result matrix also they have taken, right? So if you have to multiply, these are the two matrices M1 and M2. The values have been initialized for the two matrices. This is a 2 by 2 and this is a uh, 2 by 3. This is 2 by 2, this is 2 by 3. So they can be multiplied. You have to check that C1 is equal to R2. This C1 is equal to R2. If both are equal, then they can be multiplied. So if, then you will call the multiply matrix M1 and M2 are passed here to the matrix here, right? And then you will use three for loops to multiply. Again, result ij plus is equal to M1 ik into M2 kj. This is a C implementation of that, what they have told. But if we are using three multiplications, three for loops, that means a normal will give you O n cube. Three for loops means three loops have to be uh, uh, three times the loop will be running, so it will be n cube, and O n cube will be the complexity of this. But we have to use a different algorithm to uh, make the complexity less than this. So in divide and conquer strategy, we say that if the problem is large, we break the problem into small problems called sub problem and solve those sub problems and combine solution of sub problems to get the solution of the main problem. Now, what will be the size of the sub problem? If we have 2 by 2 matrices, we can multiply that without applying divide and conquer. But if we have larger size matrices, then we need to divide those matrices and solve the smaller matrices to get the final solution. So what they are saying is, if it is a 2 by 2 matrix, dividing normally will not be a problem, the normal multiplication which we are doing. But if we have more than this size of matrices and we have to multiply them, then we have to divide the matrices into smaller matrices, and then we have to get the final solution. So suppose here, find the multiplication in C matrix for multiplying A and B. So this is the result: A11 into B11 plus A12 into B. This was what we saw. To multiply the 2 by 2 matrices A and B, we don't need to use the three loops. We can perform multiplication using above formula. So if you see here, uh, this like we were doing according to this formula, right? And we were using three loops to solve the matrix multiplication in C. But you could also use this formula to solve your this 2 by 2 matrix. So if you have to find out what will be the value at C11, if you have two matrices A and B, these are the two matrices you have, A and B, what will be the formula C11? What will be the first index, first value at that C11? So it will be A11 into B11. So A11 into B11 plus A12 into B21. So this will be the first index value, A11 into B11 plus A12 plus into B21. Now what will be C12? C12 will be C12 will be A11 into B12 plus A12 into B22. So this will be your second, A11 into B12 plus A12 into B22. This will be the second value. Then the third one will be this one, A21 into B11 plus A22 into B21. This will be the this value, and A22 will be A21 into A21 into B12 plus A22 into B22. So this will be the fourth index value, right? So this with this formulas, you do not need these three loops. You could also solve it according to these formulas. Yes, according in C also, or in any Python or in any language, you could apply this formula and you could find out the what values accordingly. You could do that also instead of using the three formulas. So we can perform multiplication using above formula that take 8 multiplication and 4 additions. This is a constant time computation and this is defined as a small problem. Now, what if matrix size is greater than 2? Then we need to divide the matrix and solve the small matrices to get the final multiplication. We assume that matrices having dimension of power 2 only, like 4 into 4, 8 into 8, 16 into 16, and so on. Well, we assume that matrices having dimension of power 2, 2 to the power dimension is there. So power of two matrices are easy to divide into smaller sizes of 2 by 2, and if any matrix is not of power 2, then fill it with zeros to make it power of 2. So we want to multiply the product of two n into n matrices, and if n is an exact power of 2, that is n is equal to 2 to the power k, we divide each of a, b, and c, where the result will be stored into n by 2 into n by 2 matrices. So what they are saying is, suppose these are the two matrices with dimension 4 into 4. So 4 rows, 4 columns, 4 into 4, a and b are 4 into 4 matrix, that is power of 2. So that is no problem. Generally we will be considering that the power of the great power of two dimension is there, so that is okay, we will take that. Now the matrix multiplication of above two matrix will give you a result like this. Again, 4 by 4 dimension matrix will come out as a product after multiplying a into b. Right. So what is the formula of this C11 to find C11, C12, C13? What are the formulas? So this is the formula. C11 will be equal to A11 into B11 plus A12 into B21 plus A13 into B31 plus A12 into B41. This first row of A and first column of B are multiplied. So that will be the first element. Then C12 will be the C12 will be first row of A and second column of B. Then C21 will be first row of this, uh, C13. I'm talking about C13 will be first row of this and third column of B. Then C14 will be first row of A and fourth column of B. This way, just giving an example. Then what will be 2 1? 2 1 will be again this will be second row of A and first column of this will be C 21, right? And C22 will be again first row of this and second column of B will be 2 2. So this way they have given you. So now let's look at the divide and conquer approach to multiply matrix. So according to our formula, what we multiply with the first row of A and the column of B, we keep on multiplying and adding and getting the elements. So in the divide and conquer approach, take two sub-matrices from the above two matrices A and B each, like A11 and A12 and B11 and B21 are shown below. So here they are saying you have a 2 by 2 matrix. So from this matrix, we have taken A11 to A11, A12, A21, A22. These are the one sub matrix. A13 14 23 24, this is another sub matrix. 2 by 2 matrix we are finding. So again from B also, B11 B12 B21 B22, this is one, and B31 B32 B41 B42, this is a matrix. So these four matrices we have found out. Now A11 we add the and the matrix multiplication of two by two matrices A11 and B11 is A11 A12 A21 A22 into B11 B12 B21 B22. So this matrix, this one will be multiplied with this one, that will be A11, right. So we have multiplied this like this, right. And we will also get so A11 and B11 they are talking about, and we will multiply it like this. So we will get A11 uh, this one, and another is a with this one we are also getting A2 A11 into B11 plus A12 into B21. So this will be the first element. Then A11 into B12 plus A12 into B22. So this will be the second element. Then A21 into B11 plus A22 into B21. This will be the second row's first element, and so on. So this we have, this is one thing. This is the one 2 by 2 matrix we have multiplied. The matrix multiplication of two matrices A12 and B21 is as follows. So if you are saying this and this, if you are multiplying, this A12 and this B21. So you are finding A12, this A14, A23, 24, B31, B32, B41, B42, this with this. So if you have to do that again, you are finding out the two multiplication. So if you observe, I can conclude the following, that A11 into B11 plus A12 into B21 will give you these elements: C11, C12, C21, C22. These are the elements you will get if you multiply this with this and this with this, the sub arrays. So where plus is matrix addition and C11, C12, C21 and C22 are equal to equation 1, 2, 1, 2, 3 and 4. So these are the values you will get: C11, C12, C21, C22. These are the values you will get according to equation 1. This will give you these values. That is what they are saying. So the idea is to recursively divide n into n matrices into n by 2 matrices until they are small enough to be multiplied in the naive way, more specifically into 8 multiplications and 4 matrix additions. So that is what we have to do. So that is what they are talking about. So they are giving you C11, C12, C21, C22. So this is how they have calculated. I'm just so they so that algorithm which they are talking about is known as Strasson's matrix multiplication algorithm. So that algorithm is known as Stratton's multiplication algorithm. Makes use of the same divide and conquer approach, but instead uses 7 recursive calls rather than 8, as shown in the equation below. Here we can say one recursive call, but have several new addition and subtractions n by 2 matrix. So divide the input matrices A and B into n by 2 submatrices, which takes this much time. Now calculate the 7 submatrices M1 to M7 by follow. The formulas for M1 to M7 are given here. M1 will be equal to A11 plus A22, B11 plus B22, M2 will be equal to A21 plus A22 into B11. So this is the formulas. To get the desired sub matrices C11, C12, C1 of the result matrices C by adding, now you have found out M1 up to M7, you have to found out with this formula. You have to remember these formulas. If you have found out these formulas, according to this formula, the values, now what will be the value of C11, C12, C21 and C22? So C11 will be M1 plus M2, sorry, M1 plus M4 minus M5 plus M7. These are the values you will get for C11. C12 will be M3 plus M5. C21 will be M2 plus M4. C22 will be M1 minus M2 plus M3 plus M6. So this is how they are talking about. So here again they have given you an example. So here these are the two matrices you have to multiply A into B. This is A, this is B. Again, this is a 4 by 4 matrices divided into two parts. So A11 is this part, right? A12 is this part, right? A21 is this, A22 is this. Then B11 is this, B12 is this, B21 is this, B22 is this. So they have you are divided it into the subparts of uh, 4 by 4 matrices into a 2 by 2 matrices you have divided. Now Stratton showed how matrix C can be computed using the 7 block multiplication. So this formula you will apply. You will find out M1 to M7 according to this formula. So A11 plus A22. So so you will add this, then this and this, B11 and B22. So you will add it and multiply them. First, add the two matrices, right? This and this, and then you have to multiply them. Then A21 plus A22, you will add it and multiply it with this. So you find out the 7 formulas M1 to M7, whatever the values are according to this formula, you will find out. Then you will go for this. You have to find out C11, C12, C21, C22. These you have to find out according to those formulas. Then you will add up, or whatever the formulas are given, you will do accordingly, right? The correctness of the above equation equally verified by substitution. So P1 is equal to A11 plus A22 into B11 plus B22. So this is the formula. So they have added it. So you will add it and you will get this values. You will multiply it. These are the values you will get. So that is what they are talking about. So you will find out P1, P2, that is M1, M2 up to M7. You will find out. Then C11, C12, C21, C22 are the values you have found out like this, right? So this is 17, 22, 21, 18. So 17, 22, 21, 18. Then 31, 30, 33. So 31, 30, 33, 33, and 11, 25, 14, 3. This is C20. So here you have put it, and 22 to 38, 14, 30. Here you have put it. So this is your final product of A into B of a larger matrix, right? So what they are telling you is, so generally, for the case one of master theorem, the time complexity of the above approach is O n log 28 or O n q, which is the same as name method. So according to this, this method, matrix multiplication method, gives you a O n cube same method, but Stratton's give you a little small, a little less, is little less, 2.81 q n to the power 2.81. It comes out to be not n to the power 3, it is 2.81, n to the power 2.81. So generally Stratton method is not preferred for practical application for the following reason: the constant used in Stratton method are high, and for a typical application, name method works better. For sparse matrices, there are better methods specially designed for them. The sum matrices in recursion takes extra space. Because of the limited precision of computer, arithmetic, or non-integer values, larger errors accumulate in Stratton's algorithm than in name method. So they are saying generally, practically, Stratton method is not used, but it takes a little less time. Only that is there, but practically it is not possible to use this method because it will be taking extra space for finding out the solution to the problems. That is what they are, right? So this is again, they are talking about which designing approaches used in Stratton's matrix multiplication algorithm. What is the time taken by statics algorithm to perform multiplication? The time taken is O n to the power 2.81, right? And in Stratton matrix multiplication C is equal to A into B, the matrix C can be computed using only 7 block multiplication and 18 block addition or subtraction. How many addition and how many subtractions are there out of 18? So that is what they are finding out, and they have given you multiply these two matrices. It is already 2 by 2 matrix, so it is not a problem to multiply these two matrices. We do not need to further divide it into anything. We just need to take this one, this and multiply it with the first column, and this multiply with the second column. So this way you can find out the approach. So these are the divide and conquer. So your check progress questions are already given to you. You can check it. The answers are there. So this is uh, what you say, the unit 2 was all about, right? So, any doubt in divide and conquer approach? You have talked. We have talked about binary search. We have talked about sorting algorithm, quick sort and merge sort. We have talked about integer multiplication, which is Karastuba method, and we have talked about Stratton's matrix multiplication. These are the algorithms you have studied. Any doubt? Any doubt? Anybody? So,
नो मैम, एक बार चेक करना पड़ेगा
हाँ,
करके।
वो तो करना ही है प्रैक्टिकल में। प्रैक्टिकल में आपको
जी।
मतलब थ्योरी में तो आपको एल्गोरिथम पता होना चाहिए कैसे आप लिखोगे। कई बार आपको ये भी पूछा जा सकता है कि इसको आप इस एल्गोरिथम के या इस स्ट्रैटेजी के अकॉर्डिंग सॉल्व करके दिखाइए। तो जैसे हमने अभी देखा ना कैसे सॉल्व किया है मैट्रिक्स मल्टीप्लिकेशन या स्ट्रैटन मल्टीप्लिकेशन, जैसे आपने सॉल्व किया है इसको सॉल्व करके ऐसे ही आपको दिखाना पड़ेगा। कई बार मतलब आप, इसलिए मैंने बोला प्रीवियस ईयर।
मैम
हाँ जी,
मैम ये जैसे पेपर में ये कोडिंग लिखने के लिए आएगी प्रोग्राम, या ये एल्गोरिदम भी लिख सकते हैं?
एल्गोरिथम ही लिखना है आपको। प्रैक्टिकल में कोडिंग होगा। जैसे अगर मैं आपको, आई डोंट नो आपकी वेबसाइट खुल रही है कि नहीं। सो इग्नू की वेबसाइट पे क्वेश्चन पेपर्स, प्रीवियस ईयर क्वेश्चन पेपर्स अवेलेबल हैं अभी। आई थिंक दिसंबर 2024 तक का पेपर है। आई डोंट नो वो भी है कि नहीं है, आई एम जस्ट सीइंग। नहीं, ये नहीं है अभी अवेलेबल, इन्होंने अपलोड नहीं किया है, तो जून 2024 का अवेलेबल है। तो विल गो फॉर जस्ट से कंट्रोल F, SOCIS, ये आपका स्कूल है, स्कूल ऑफ कंप्यूटर एंड इंफॉर्मेशन साइंसेस। वो आपको सर्च करना पड़ेगा SOCIS, क्योंकि बहुत सारे अदर स्कूल्स भी आएंगे कोर्सेज। तो आपके कोर्सेज MCA, BCA, CIT, बहुत सारे कोर्सेज हैं कंप्यूटर्स के, वो SOCIS के अंदर आते हैं। तो आप इसको खोलेंगे SOCIS वाला। अब इसके अंदर CIT, बैचलर, BCA, PGDCA, MCA न्यू आपको जाना है। गो फॉर MCA न्यू एंड डिजाइन एंड एनालिसिस ऑफ एल्गोरिथम का आप थ्योरी पेपर यहाँ देख सकते हो। ये रहा आपका थ्योरी पेपर, right? So always your question paper will be of 3 hours, right? Maximum marks is 100 and question number 1, maximum papers जितने भी theory papers हैं, question number 1 will be compulsory and you have to attempt any 3 questions from the rest. So there are 5 questions total. Question number 1 will be compulsory and from the rest 2, 3, 4, 5 you have to attempt any 3. Right. So again, they are talking about use mathematical induction to prove this. Right. This is question 1 ka A part. So question number 1 is compulsory. So it will be around 40 marks question. Question number 1 will be a 40 marks. So पूरे syllabus में से कोई ना कोई question आ ही जाएगा आपको. What is recursive binary search algorithm and analyze its complexity in worst case scenario? So recursive binary search algorithm इसी ब्लॉक में हमने अभी पढ़ा था। जो ये वाला ब्लॉक है, इसी में हमने शुरू में बाइनरी सर्च एल्गोरिथम पढ़ा था। ये रहा, right? So this is what the binary search algorithm, recursive binary search algorithm will be doing. So ये, और इसका जो worst case scenario में जो भी इसका वो है, this is the time complexity, तो वो आपको बताना है, right?
ओके मैम, थैंक यू।
तो इस तरह से क्वेश्चन पेपर आपको आने वाला है। व्हाट इज एन एल्गोरिथम, एक्सप्लेन कैरेक्टरिस्टिक्स ऑफ एन एल्गोरिथम विद द हेल्प ऑफ एन एग्जांपल। ये आपको जो फर्स्ट यूनिट, ब्लॉक 1 का फर्स्ट यूनिट में है। नाउ मल्टीप्लाई द फॉलोइंग टू मैट्रिक्स यूजिंग स्टैटन्स एल्गोरिथम। यहाँ आ गया ना यही क्वेश्चन जो अभी हमने स्टैटन्स एल्गोरिथम देखा था, तो वही क्वेश्चन यहाँ पे आ गया है। अब ये ऑलरेडी 2x2 में सॉर्टेड है, आपको कुछ नहीं करना है, फॉर्मूला बस ये इसको इससे मल्टीप्लाई करना है, वो पहला आ जाएगा, इसको इससे मल्टीप्लाई करना है, वो दूसरा वैल्यू आ जाएगा। इस तरह से आपको करके दिखाना है। ये अभी फोर्थ ब्लॉक है, व्हाट आर पी एंड एनपी क्लास ऑफ प्रॉब्लम, डिफरेंशिएट एनपी हार्ड एंड एनपी कंप्लीट प्रॉब्लम। इसमें ज्यादातर इसी तरह के क्वेश्चन आते हैं, फोर्थ ब्लॉक में ज्यादा नहीं आता है। ठीक है, फर्स्ट, सेकंड एंड थर्ड ब्लॉक आर इंपॉर्टेंट। एक्सप्लेन क्विक सॉर्ट एल्गोरिथम यूजिंग सुटेबल एग्जांपल। अगेन क्विक सॉर्ट मैंने जो हमने एल्गोरिथम देखा था, तो आपको एक्सप्लेन करना है वो एल्गोरिथम क्या करता है और आपको एक एग्जांपल देके बताना है। फिर मल्टीप्लाई द फॉलोइंग टू नंबर्स यूजिंग कैरेस्टूबा एल्गोरिथम। नाउ यहाँ पे कोई नंबर नहीं दे रखा है, इन्होंने दिया नहीं है। आप कोई भी 2 नंबर ले लो, x और y, x इज इक्वल टू 1 2 3 4 या y इज इक्वल टू 5 6 7 8, जो भी ले लो, जैसे उसमें दिया हुआ था एग्जांपल, और कैसे आप कैरेस्टूबा मेथड से मल्टीप्लाई करके दिखाते हो उसे, वो आपको करके दिखाना है, मतलब प्रोसेस। व्हाट इज स्ट्रिंग मैचिंग एल्गोरिथम। जो स्ट्रिंग मैचिंग एल्गोरिथम आगे देखेंगे हम, वो डिराइव इट्स बेस्ट टाइम कम्प्लेक्सिटी, तो वो स्ट्रिंग मैचिंग एल्गोरिथम आपको बताना है। ये फर्स्ट क्वेश्चन है, राइट? ज्यादातर एल्गोरिथम ही पूछे जाएंगे, यहाँ पे कोई प्रोग्राम लिखने को नहीं आएगा। प्रैक्टिकल में आपको इंप्लीमेंट करके दिखाना है, थ्योरी में नहीं। तो सेकंड क्वेश्चन इज व्हाट इज मिनिमम स्पैनिंग ट्री, राइट प्रिम्स एल्गोरिथम फॉर फाइंडिंग मिनिमम स्पैनिंग ट्री एंड फाइंड इट्स टाइम कम्प्लेक्सिटी, ऑल्सो फाइंड मिनिमम स्पैनिंग ट्री ऑफ द फॉलोइंग ग्राफ यूजिंग प्रिम्स एल्गोरिथम। तो यहाँ पे आपको एक तो बताना है मिनिमम स्पैनिंग ट्री होता क्या है, देन यू हैव टू टेल प्रिम्स एल्गोरिथम आपको बताना है। अगर आपको फाइंड करना है प्रिम्स एल्गोरिथम से मिनिमम स्पैनिंग ट्री, तो एल्गोरिथम क्या है वो लिखना है, राइट द प्रिम्स एल्गोरिथम, एंड यू हैव टू आल्सो टेल द टाइम कम्प्लेक्सिटी ऑफ दैट एल्गोरिथम क्या है। उसके बाद आपको ये सॉल्व करके दिखाना है प्रिम्स एल्गोरिथम के अकॉर्डिंग ये ग्राफ, Then write an algorithm for topological sort, obtain a topological ordering for the following graph. तो इसमें topological ordering वाला algorithm आपको लिखना है और ये इसकी topological sorting करके आपको ordering करके आपको दिखानी है. देन थर्ड क्वेश्चन इज, अब सेकंड, थर्ड, फोर्थ, फिफ्थ में से आपको 3 करने हैं कोई भी. अब वो कोई भी एक आप छोड़ सकते हो इसमें से. The best case analysis is not as important as the worst case analysis of an algorithm. So yes or no, justify your answer with the help of an example. So best case analysis is not important, but worst case is important. ऐसा क्यों है आपको बताना है एग्जाम्पल देके. Sort the following sequence of numbers using selection sort. Also find the number of comparison and copy operation required by algorithm is sorting this list. तो ये selection sort के according आपको sort करना है और बताना है कि कितने comparison और कितना copy operation और कितने comparison आपको करने पड़े ये sorting करने के लिए. फोर्थ में है आपका हम knapsack 01 knapsack प्रॉब्लम जो आपके आएगी लेटर ऑन. हम हाँ 1/2 नैपसैक तो कर चुके हैं. 01 नैपसैक अभी हम करेंगे लेटर ऑन. तो उसको सॉल्व करना है आपको. अब ये आपको दिया हुआ है कितना आपके ऑब्जेक्ट्स हैं, कितना आपका साइज ऑफ द नैपसैक है और क्या उसका प्रॉफिट और वेट कितना है प्रोडक्ट का, वो सब दिया हुआ है. उसको सॉल्व करना है आपको, मतलब दिखाना है सॉल्व करके. एक्सप्लेन द 01 नैपसैक प्रॉब्लम क्या होती है और फिर उसके बाद इसको सॉल्व करके दिखाना है अकॉर्डिंग टू दैट. Now give a divide and conquer based algorithm to find the ith smallest element in an array of size n. Trace your algorithm to find third smallest in the array. तो अगेन आप डिवाइड एंड कॉन्कर एल्गोरिथम का यूज कर सकते हो. तो आप इसमें आपको क्या करना है, आपको स्मॉलेस्ट एलिमेंट फाइंड आउट करना है, फिर आपको थर्ड स्मॉलेस्ट एलिमेंट फाइंड आउट करना है. तो वो कैसे करके दिखाओगे, वो उसका एल्गोरिथम बताना है और इसको सॉर्ट करके दिखाना है. फिफ्थ है write Dijikra's algorithm to find the shortest path in a graph. Apply Dijikra's algorithm. Again आपको उसका एल्गोरिथम लिखना है, Dijikra कैसे शॉर्टेस्ट पाथ फाइंड करता है और फिर इसी ग्राफ पे आपको उसको दिखाना है कि शॉर्टेस्ट पाथ क्या होगा इसका. फिर अप्लाई फ्लॉयड वॉशल एल्गोरिथम टू फाइंड द शॉर्टेस्ट पाथ डिस्टेंस बिटवीन ईच पेयर ऑफ वर्टिसेस. इसमें आपको फ्लॉयड एल्गोरिथम बताना है और इसको फ्लॉयड एल्गोरिथम के अकॉर्डिंग सॉर्ट करना और उसकी टाइम कम्प्लेक्सिटी बतानी. ये मतलब एक एग्जाम्पल है, इस तरह का पेपर आएगा. आप प्रीवियस जैसे मैं आप पीछे जा रही हूँ, 2020 जून 2024, दिसंबर 2023, जून 2023, दिसंबर 2022, जून 2022. ये 5 पेपर्स आप डाउनलोड कर लो, प्रीवियस 5 इयर्स पेपर्स. तो इस तरह का मैक्सिमम इस तरह के क्वेश्चंस आपको एग्जाम में आएंगे. अंडरस्टूड?
ओके मैम, थैंक यू.
दिस इज
मैम,
हाँ जी.
मैम ये पूछना था, ये जो आप ये पीडीएफ है ये कहाँ से डाउनलोड कर रहे हैं? ई ज्ञान कोश से?
ये हाँ, वैसे तो ई ज्ञान कोश पे है. अब आई थिंक ई ज्ञान कोश खुल नहीं रहा है, शायद खुल रहा है कि नहीं.
हाँ, कभी कभार खुलता, कभी कभार नहीं.
खुल रहा है, अब खुल रहा है. वो शायद वेबसाइट तब वर्क नहीं कर रही थी. ये सारे ब्लॉक्स आपको अवेलेबल है, ब्लॉक 1, ब्लॉक 2, ब्लॉक 3, ब्लॉक 4. वो यहाँ पे क्लिक करेंगे और यहाँ से आप अगर पूरा ऐसे यूनिट, वो अलग अलग यूनिट्स नहीं डाउनलोड करने, तो आप ये ब्लॉक 1 दिख रहा है आपको?
यस मैम.
और ये पूरा ब्लॉक में यूनिट 1 to 4 पूरा ब्लॉक डाउनलोड हो जाएगा एक साथ, अलग अलग करने के बजाय. ठीक है,
ओके मैम, थैंक यू.
तो वो आप कर सकते हो. ये आपको ई ज्ञान कोश से सारी बुक्स मिल जाएंगी. जो एलएमएस पोर्टल पे हैं, जो एमसीए ओएल के स्टूडेंट्स हैं, उनको तो एमसीए ओएल की वेबसाइट पे मिल जाएगा, मतलब उन पोर्टल पे मिल जाएगा. आप उस सब्जेक्ट को क्लिक करिएगा और उस सब्जेक्ट के अंदर ही व्हेन यू क्लिक ऑन दैट सब्जेक्ट, पर्टिकुलर सब्जेक्ट, द बुक्स विल बी अवेलेबल देयर ऑल्सो, स्टडी मटेरियल.
एलएमएस पोर्टल पे मैम?
हाँ, वहां पे भी है. एलएमएस पोर्टल आप
ओके.
एक्सेस करिए, आपका सब्जेक्ट पे क्लिक करिए. एमसीएओएल के स्टूडेंट्स जो ओडीएल मोड के हैं वो यहाँ से डाउनलोड कर सकते हैं ई ज्ञान कोश से, और जो ओएल वाले हैं वो तो वो एलएमएस पोर्टल से भी ले सकते हैं. यही बुक होंगी, सेम ही बुक है, ऐसा डिफरेंट नहीं है. एलएमएस पोर्टल पे भी अवेलेबल है. आपके, आप लॉग इन कीजिए अपने एलएमएस पोर्टल पे, अपने सब्जेक्ट पे क्लिक करिएगा, तो वहां पे आपको स्टडी मटेरियल आएगा, बुक आएगी वहां पे।
ओके मैम, थैंक यू, थैंक यू।
हेलो मैम।
नाउ वी आर, हाँ जी।
एक वो जो प्रैक्टिकल सेशन वाले असाइनमेंट कैसे सॉल्व करने का?
प्रैक्टिकल असाइनमेंट में इम्प्लीमेंट करना है, तो दैट इज योर विश। आप जिस प्रोग्रामिंग लैंग्वेज में कन्वर्सेंट हैं, आपको अगर वो पूछता है कि इम्प्लीमेंट knapsack प्रॉब्लम, सो यू हैव टू इम्प्लीमेंट इन अ पर्टिकुलर प्रोग्रामिंग लैंग्वेज, दैट कैन बी सी, दैट कैन बी पाइथन, दैट कैन बी जावा, वट एवर यू आर कन्वर्सेंट विद, सी प्लस प्लस, जो भी आप कन्वर्सेंट है उस लैंग्वेज में आपको इसको इम्प्लीमेंट करके दिखाना है, राइट?
Okay.
Right, and you know that you have a study material for your practical book also is also there. Yes or no? Everybody knows that
नो मैम।
there
Yes,
is a
ma'am.
practical study material also. MCSL 216 is your practical lab book. तो जब अगर जो OL मोड के स्टूडेंट्स हैं, दो दे विल फाइंड MCSL 216. L means lab, MCS means theory paper, MCSL, L means lab, that is practical,
ये कहाँ से
right?
होगा मैम डाउनलोड?
वही सेम जैसे मैंने अभी
ओके
211
ओके।
डाउनलोड किया, MCSL 216 भी डाउनलोड कर सकते हो, और वही चीज आपको LMS पोर्टल पे भी MCSL 216 वाला कोड क्लिक करोगे तो स्टडी मटेरियल वहां पे भी मिलेगा।
ओके ओके मैम,
ठीक है, तो
थैंक यू।
लैब बुक है ये आपकी, राइट? तो अब इस लैब बुक में अगर आप जाओगे नीचे, तो सेशन नंबर 1 अगर आप देखोगे यहाँ पे, ये प्रॉब्लम इम्प्लीमेंटेशन है, तो ये पहला क्वेश्चन बोल रहा है कि आपको जीसीडी यानी यूक्लिड एल्गोरिथम से जीसीडी निकालना है, ग्रेटेस्ट कॉमन डिवाइजर निकालना है। क्वेश्चन नंबर 2 हॉर्नर्स रूल से ये पॉलिनोमियल हमने ये किया था, तो पॉलिनोमियल निकालना है। क्वेश्चन नंबर ये ब्रूट फोर्स हॉर्नर्स मेथड से मल्टीप्लिकेशन करना है। क्वेश्चन नंबर 3 ये नॉर्मल इम्प्लीमेंट मल्टीप्लिकेशन ऑफ टू मैट्रिसेस एंड कैलकुलेट, ये नॉर्मल मल्टीप्लिकेशन है, और ये कह रहा है हाउ मेनी टाइम्स द इनर मोस्ट एंड आउटर मोस्ट लूप विल रन एंड टोटल नंबर ऑफ मल्टीप्लिकेशन एंड एडिशन। तो आपको अभी भी हमने देखा था कितने नंबर ऑफ मल्टीप्लिकेशन होते हैं, राइट? जो अभी हम स्टैटन्स एल्गोरिथम कर रहे थे उसमें भी वो बता रहा था ना, इतने नंबर ऑफ टाइम नॉर्मल में मल्टीप्लिकेशन होता है और इतना एडिशन होता है, right? Then implement left binary exponentiation, तो राइट एंड लेफ्ट बाइनरी एक्सपोनेंशिएशन ये भी हमने किया था, बट अगर हमारे पास टाइम होगा तो लास्ट सेशन जो लास्ट क्लास है आपकी, एक बार दोबारा इसको रिपीट कर देंगे जिन्होंने अटेंड नहीं किए हैं पहले वाले सेशंस। ठीक है, तो ये भी आपको बोला हुआ है। अब इम्प्लीमेंट करना है, इम्प्लीमेंट का मतलब है यू हैव टू राइट अ प्रोग्राम, उस एल्गोरिथम को इम्प्लीमेंट करना है ना, तो you have to write the program and show that कितने loops हो रहे हैं, how many times the loop is running, how many multiplication and addition are there. Then this is bubble sort algorithm, bubble sort से इसको sort करना है आपको, और again ये कह रहा है कितने exchange हो रहे हैं, number of comparisons कितने, number of times the inner and outer loop चल रहे हैं, again किसी एक programming language में आपको implement करना है इसको। Then implement selection sort algorithm, ये selection sort के according आपको इसको sort करना है। तो all these problems we will do it in the practical session, जब practical session start होंगे। तो फिर फ्रैक्शनल नैपसैक है, ये हम कर चुके हैं, फ्रैक्शनल नैपसैक मतलब इसका एल्गोरिथम कर चुके हैं, इसको कैसे इम्प्लीमेंट करना है सी, पाइथन या जिस भी प्रोग्रामिंग लैंग्वेज में, तो वो देखना है हमें। टास्क शेड्यूल देखो, programming when we talk about a programming language, only the syntax is different of the programming languages, but the way of doing an algorithm is the same. Can you understand that? Everybody understands that?
यस मैम।
Yes, ma'am.
लॉजिक वही रहेगा प्रोग्राम को करने का, ओनली थिंग इज द वे ऑफ राइटिंग द सिंटैक्स ऑफ दैट पर्टिकुलर प्रोग्रामिंग लैंग्वेज विल बी डिफरेंट। पाइथन का थोड़ा डिफरेंट होगा, सी का थोड़ा डिफरेंट होगा, सी प्लस प्लस का थोड़ा सा डिफरेंट, मतलब सी और सी प्लस प्लस में थोड़ा कंपैरिजन तो सेम ही है, थोड़ा सा डिफरेंट होता है, सी आउट और सी इन सी प्लस प्लस में यूज होते हैं, बाकी मैक्स और क्लास सी प्लस प्लस में क्लासेस का भी कॉन्सेप्ट है, बाकी तो सब सी और सी प्लस प्लस में सेम ही होता है, राइट? और पाइथन भी सी की तरह ही है, ओनली थिंग इज पाइथन का लिखने का तरीका या उसका सिंटैक्स इज अ लिटिल डिफरेंट फ्रॉम व्हाट, वी डोंट हैव कर्ली ब्रैकेट्स, वी डोंट यूज कर्ली ब्रैकेट, सेमीकोलन, ये सब हम यूज नहीं करते पाइथन में, राइट और इंडेंटेशन का यूज किया जाता है वहां पे, कोलन का यूज किया जाता है फॉर टेलिंग दैट दिस इज द पार्ट ऑफ इफ और फॉर और वट एवर, राइट। तो वो डिफरेंस है, बाकी तो लॉजिक सेम ही रहता है प्रोग्रामिंग लैंग्वेज के अकॉर्डिंग। तो अब ये सेशन नंबर 3 टास्क शेड्यूलिंग एल्गोरिथम है, ये भी हम कर चुके हैं। इसके अकॉर्डिंग क्वेश्चन उन्होंने पूछा हुआ है, जैसे कि ये क्वेश्चन पूछा है उन्होंने, जॉब अगर हम जॉब्स को करते हैं वो क्या होगा, और इम्प्लीमेंट करने को बोला है कि अगर ये जॉब्स आपको दी हुई हैं तो इसको कैसे शेड्यूल करोगे टास्क शेड्यूलिंग एल्गोरिथम से। तो ये सारे क्वेश्चन आपको अकॉर्डिंगली दिए हुए हैं। ये हाफमैन कोडिंग का है, ये भी हम कर चुके हैं, राइट। देन डिवाइड एंड कॉन्कर का आ गया यहाँ पे, इसमें इन्होंने बाइनरी सर्च एल्गोरिथम का करने को बोला है ये इम्प्लीमेंट। देन मर्ज सॉर्ट एल्गोरिथम है, क्विक सॉर्ट एल्गोरिथम है, स्टैटन्स मल्टीप्लिकेशन एल्गोरिथम है। तो ये इम्प्लीमेंट करने हैं। और फिर अब जो हम स्टार्ट कर रहे हैं, वी विल बी स्टार्टिंग ग्राफ्स। तो हम डिजेक्ट्रा एल्गोरिथम और प्रिंस एल्गोरिथम, ये सब मिनिमम स्पैनिंग ट्री, ये सब हम करेंगे। दैट इज व्हाट दैट इज, दिस इज योर अनदर स्टडी मटेरियल, प्रैक्टिकल स्टडी मटेरियल है ये। अंडरस्टूड? MCSL 216। तो ये प्रैक्टिकल में करेंगे। और अभी जो है आपका दिसंबर में जो है आपका थ्योरी एग्जाम होगा, right? In January, in end of January or probably whatever time, your practical examination will be there. Those who are MCA OL student, right? Those who are MCA OL student, online mode students, they will have probably the practical in Viva based format, right? As आपको एक link दिया जाएगा, you have to join that link, and a Viva based format practical will be there for OL. For all those who are ODL mode students, for them a center will be allotted to you, and you have to go to that center, and there will be a question paper there, and you have to show them the there will be computers also available, and you have to show them the implementation, right?
मैम प्रैक्टिकल सेशन होंगे क्या सेंटर पे?
प्रैक्टिकल सेशन आपका ओएल मोड है,
नहीं,
एमसीए ओएल है,
ओडीएल है, ओडीएल है।
आई डोंट नो। ओडीएल मेरे ख्याल से ओडीएल और ओएल दोनों का आई डोंट नो। ओएल ऑनलाइन मोड में ही हो रहा है आपका। आपको क्या वो आया है,
अभी
ईमेल
तक
क्या
कोई
आया है,
नहीं,
शेड्यूल?
मेल नहीं आया है, शेड्यूल का कोई मेल नहीं आया है।
तो आपने कैसे ज्वाइन किया है फिर यहाँ पर?
ये बार लेक्चर्स के लिए, प्रैक्टिकल सेशन के लिए कोई मेल नहीं है कि कब आना है, कब वहाँ
नहीं नहीं,
अटेंड करना है।
आई एम आस्किंग, ये जो आपको थ्योरी आप अटेंड कर रहे हो, हाउ डिड यू गेट द इंफॉर्मेशन अबाउट द थ्योरी?
मेल मेल।
तो मेल में ही तो आपका MCSL 216 का भी तो होगा ना उसमें शेड्यूल में। MCSL 216 देखो शेड्यूल में, डोंट यू हैव द शेड्यूल?
है, मेल में चेक करना पड़ेगा फिर तो।
तो उसी में ही है प्रैक्टिकल शेड्यूल भी, ऐसे ही ऑनलाइन मोड में ही है वो भी।
अच्छा, वो भी ऑनलाइन में ही है।
हाँ,
और
आपको आपको
ये
जाना
जो,
नहीं है, मैं आपको एग्जाम की बात कह रही हूँ। अभी
अच्छा
जो आप अटेंड कर रहे हो क्लासेस, मैं क्लासेस की बात नहीं कर रही हूँ, क्लासेस तो आप ऑनलाइन मोड में ही अटेंड कर रहे हो, मेरे साथ ही अटेंड करोगे। MCSL 216 का प्रैक्टिकल अभी नवंबर में स्टार्ट होंगे प्रैक्टिकल सेशंस। वो जो क्लासेस होंगी वो तो ऐसे ही ऑनलाइन होगी, मैं एग्जाम की बात कर रही थी। जब प्रैक्टिकल एग्जाम भी होगा ना, थ्योरी एग्जाम होगा एक तो आपका,
हाँ।
एक प्रैक्टिकल एग्जाम होगा आपका, वो
अच्छा,
जनवरी एंड में होगा। तो ओडीएल मोड वालों को सेंटर पे जाके रन करना होगा, ओएल वालों का ऑनलाइन मोड में ही होगा।
और मैम जो अभी 31 अक्टूबर तक असाइनमेंट सबमिट करना है, तो वो खुद से ही करना है, प्रैक्टिकल वाले भी?
हाँ जी, खुद से ही करने हैं आपको।
अच्छा।
मैम
हाँ,
सबमिट ऑनलाइन हो सकता है या फिर कॉलेज जाना पड़ेगा?
आप कौन सा क्या आपका क्या मोड है?
मैम
MCOL
MCA
है, ओडीएल है?
वो ओडीएल।
ओडीएल है तो आप कौन से सेंटर के हो स्टूडेंट?
मैम मैरिड।
मेरिट के हो ना, तो मेरिट की
यस मैम।
वेबसाइट पे एक लिंक है असाइनमेंट सबमिशन का, ऑनलाइन लिंक।
वो
आपको
ओपन नहीं हो
मेल
रहा है।
आया होगा उसके बारे में।
मैम मेरे को सिर्फ एडमिशन कंफर्मेशन का मेल आया था और कोई मेल नहीं आया। और ये क्लासेस तो आई थिंक मैं एक एक फर्स्ट सेमेस्टर का स्टूडेंट था लास्ट ईयर, जनवरी जनवरी बैच का, उसने भेजा था मेरे को ये। मेरिट की
ऐसा तो
साइट।
नहीं हो सकता। आपको कैसे पता चला कि आपका मेरिट सेंटर है?
मैम मेरिट मेरा उसमें लिखा है ना, आप
कहाँ
क्या
पे
कहते
लिखा?
हैं, रीजनल सेंटर और स्टडी सेंटर।
आपके एडमिशन पे लिखा हुआ है?
जैसे
आपके
मैम
आईडी? अच्छा,
एडमिशन कंफर्मेशन पे और आईडी कार्ड पे भी।
तो आपको मेल आना चाहिए। आपको ये एडमिशन का ईमेल पे ही इंफॉर्मेशन आई थी?
जैसे एडमिशन कंफर्मेशन का मेल मेरे को ईमेल पे आया था।
ईमेल पे आया था तो मेरिट से भी आपको मेल आई होगी कि आपका, या तो हो सकता है आपको मेल आपके स्पैम में चली गई हो।
मैम आपकी वॉइस नहीं आ रही।
मैंने कहा आपको हो सकता है आपका मेल जो है वो स्पैम में चला गया हो।
ना मैंने स्पैम चेक करा था।
अब वो मैं कह नहीं सकती हूँ, मुझे नहीं पता आपको क्यों मेल नहीं आई है, तो आपको सेंटर पे बात करनी पड़ेगी। बट यहाँ पे अगर आप देखोगे, आपका यहाँ पे देखो ये लिंक है, असाइनमेंट एंड जनरल इन्फॉर्मेशन, कैन यू सी दैट?
यस मैम।
द मेरिट्स वेबसाइट merit.ac.in। आप यहाँ पे जाइए, असाइनमेंट एंड जनरल इन्फॉर्मेशन में जाइए, राइट। ये
ओके।
आपको इंडक्शन मीटिंग का ये तो खैर बात की बात है, वी आर नॉट टॉकिंग अबाउट दैट। ये कवर पेज है असाइनमेंट का, ये आप डाउनलोड कर सकते हैं। फर्स्ट पेज आपका, आपको क्या क्या चीजें लगानी है, आपका नेम, एनरोलमेंट नंबर, ये सब होना चाहिए। आईडी कार्ड उस पर लगा होना चाहिए स्कैन में, आपको स्कैन करना है। आप हैंड थ्योरी असाइनमेंट शुड बी हैंड रिटन एंड
ओके मैम।
प्रैक्टिकल असाइनमेंट कैन बी अ सॉफ्ट कॉपी। मतलब एक वर्ड फाइल में, जैसे अगर मैं 211 का असाइनमेंट की बात करूं, तो अगर आपको ये 211 में अगर आपको इम्प्लीमेंट करना है तो आप कोड लिखोगे, राइट। प्रैक्टिकल असाइनमेंट में कोड आप उसका मतलब वर्ड में पेस्ट कर दोगे कोड, और स्क्रीनशॉट ऑफ द इनपुट आउटपुट वो पेस्ट कर दोगे। दैट इज योर इम्प्लीमेंटेशन। कैन यू अंडरस्टैंड दैट?
यस
प्रैक्टिकल
मैम।
असाइनमेंट वो आप सॉफ्ट
यस।
कॉपी कर देना, और थ्योरी असाइनमेंट आपका हैंड रिटन होगा, ठीक है।
तो असाइनमेंट तो वही करना है ना जो इग्नू की वेबसाइट पे था।
हाँ, जो
एमसीए
असाइनमेंट आपको दिया हुआ है वही करना है। 2025 जुलाई दिसंबर सेशन का 2025 वाला असाइनमेंट,
ओके
जुलाई
मैम।
दिसंबर सेशन का वही वाला करना है आपको, ठीक है।
यही
और
डाउट था
जो
कि जाना था कि जाके जमा करना है या फिर ऑनलाइन भी हो सकता
नहीं, आप ऑनलाइन करोगे, और फिर यहाँ पे सबमिशन लिंक है, आप ये देख रहे हो, टर्म एंड एग्जामिनेशन दिसंबर 2025 असाइनमेंट सबमिशन लिंक, यहाँ
है।
पे
ओके।
सबमिट करना है आपको। एक पीडीएफ में कन्वर्ट कर लेना, यहाँ पे सारी इंफॉर्मेशन दी हुई है, कैसे करना है आपको, क्या क्या करना है, ये सब कुछ लिखा हुआ है यहाँ पे। ये आपका फॉर्म है, वो जो फॉर्म जो मैं बोल रही थी, ये फॉर्म होना चाहिए आपके उसमें। आपका आईडी कार्ड भी अटैच होना चाहिए, और यहाँ पे आप सबमिट करोगे, और वो साइज भी आपको बता देगा यहाँ पे कितना साइज आपका उसका होना चाहिए, यहाँ पे
मतलब
पीडीएफ
सारे कोर्स, जितने भी कोर्सेज हैं सबके अलग अलग अपलोड होंगे।
हाँ, सबका अलग अलग अपलोड होगा।
ठीक। थैंक यू।
ठीक है, और एलएमएस पोर्टल जो सबमिशन है वो कैसे है, वो गाइड यहाँ पे दिया हुआ है। जो जो ऑनलाइन मोड है, ओ एमसीए ओएल वाले, जो जो ऑनलाइन मोड के स्टूडेंट्स हैं, दे कैन गो टू दिस एलएमएस असाइनमेंट सबमिशन प्रोसेस, गाइड दी हुई है आपको कैसे कैसे सबमिट करना है असाइनमेंट एलएमएस पे, वो यहाँ पे दिया हुआ है, राइट। गो टू दैट। लेकिन यहाँ पे सबमिट नहीं होगा, सबमिट आपके एलएमएस पोर्टल पे होगा फॉर ओएल स्टूडेंट्स। ये गाइड है बस, राइट।
मैम
अंडरस्टूड?
और जो ओडीएल वाले दूसरे सेंटर से उनको वहां जाके सबमिट करना पड़ेगा?
अब ये तो आई हैव नो आइडिया, जस्ट आस्क योर, यू हैव अ डिफरेंट स्टडी सेंटर?
हाँ, नागपुर है।
रीजनल सेंटर नागपुर होगा आपका, स्टडी
स्टडी
सेंटर।
सेंटर भी नागपुर ही है।
तो आप वहां जाके पता कर लो आपको कैसे सबमिट करना है।
अच्छा, और
आस्क द स्टडी सेंटर दैट हाउ you need to submit the assignments.
प्रैक्टिकल इधर नागपुर में भी सॉफ्ट कॉपी चलेंगे, प्रैक्टिकल की हैंड रिटन?
वो मैं हम तो यही एक्सेप्ट करते हैं। आई हैव नो आइडिया अबाउट नागपुर, यू आस्क देम,
ओके मैम।
right? I have no idea about Nagpur. You can ask them, but this is the way ODL students. तो आप वहीं आप पूछ लो कि कैसे सबमिट करना है आपका, जो जो भी स्टडी सेंटर है उनको। अगर वो एक्सेप्ट करते हैं सॉफ्ट कॉपी, तो सॉफ्ट कॉपी प्रिंट आउट निकाल के आपको सबमिट करना होगा। अगर वो मतलब हार्ड कॉपी ले रहे हैं तो
ओके।
हम्म अगर उनका कोई लिंक है ऑनलाइन तो आपको फिर स्कैन करना पड़ेगा। मतलब सॉफ्ट कॉपी को क्या स्कैन करना, वो तो वर्ड में ही बना देना। राइट, वो तो आपको अपने स्टडी सेंटर से पूछना पड़ेगा, बट दोज हु आर फ्रॉम मेरिट स्टडी सेंटर, ओडीएल मोड वाले जो मेरिट स्टडी सेंटर के हैं, उनको तो मैंने बता दिया कैसे सबमिट करना है, राइट। अब नाउ योर क्लास इज एंडिंग राइट नाउ, so we'll meet tomorrow now. We have two classes tomorrow from 10 a.m. I think. So we'll talk about the next topic we'll talk about is graph algorithm. So graph algorithm के बारे में पढ़ेंगे different, पहले तो graph के बारे में थोड़ी सी information ये दे रहा है, right, and we'll be talking about that. Topological ordering के बारे में पढ़ेंगे, then we will go for the different algorithms जो आपके हैं, Dijktra, Prince, minimum spanning tree algorithms जो हैं उनके बारे में पढ़ेंगे। फिर बाद में हम टॉपिक स्टार्ट करेंगे डायनेमिक प्रोग्रामिंग टेक्निक, वो लेटर ऑन की बात है। सो दिस इज व्हाट टुडेज थिंग्स आर, राइट।
ओके मैम, थैंक यू फॉर दिस इंफॉर्मेशन।
मैम एक चीज़ पूछना था। हेलो
हाँ जी, बोलिए बोलिए बोलिए।
मैम, कोई व्हाट्सएप ग्रुप नहीं बनाया, कोई डाउट आया तो कुछ पूछने के लिए किसी
आई
रिलेटेड?
थिंक बना हुआ है ना क्लास।
यस मैम।
मैम मैं भी व्हाट्सएप ग्रुप में नहीं हूँ।
आप जो जो उसका एडमिन है या जो हेड है, प्लीज वो लिंक यहाँ पे चैट बॉक्स में डाल दो, वो लिंक ज्वाइन करने के
यस
लिए
मैम।
स्टूडेंट्स के लिए।
अनऑफिशियल है वो, ऑफिशियल ग्रुप नहीं है।
ये अनऑफिशियल ऑफिशियल क्या है? लास्ट टाइम मुझे दिया था, मैं भी ज्वाइन नहीं कर पाई थी वो ग्रुप।
मैम मैं भी नहीं हूँ ग्रुप में ज्वाइन।
ऑफिशियल थोड़ी है कोई, जो भी है अनऑफिशियल ही है, उसमें ही सब कुछ आता है।
हाँ जी भाई, उसकी लिंक दे दो यार,
बिल्कुल भाई।
unofficial दे दो।
ऑफिशियल कोई ग्रुप नहीं है, कोई मेरिट ने कोई ग्रुप नहीं बनाया है। आई एम जस्ट सेइंग व्हाटएवर ग्रुप यू हैव,
उसकी
जस्ट
लिंक
मेक
प्रोवाइड कर दो।
दैट ग्रुप ओनली, और उस ग्रुप के मेंबर बन जाते हैं। तो आप वो लिंक डाल दो जो भी ग्रुप है।
जी मैम।
इनवाइट कोड डाल सकते हो।
चलो उधर ही कल आके ना मैं चेक भी ले आऊंगा, क्रेडिट कार्ड भी ले आऊंगा। हाँ
राइट, डाल दिया है।
डाल दिया।
सही बात हुई है उन्होंने।
Ma'am, what about the
ज्वाइन कर
attendance?
लीजिए जो जो स्टूडेंट्स ज्वाइन करना चाहते हैं इस
सतन नाम ये कौन है? सतन नाम सतन।
हाँ, ज्वाइन दिस ग्रुप, आई विल आल्सो ज्वाइन इट।
आपकी मेल आईडी है ना जो gmail.com।
ओके मैम।
And everybody has put their attendance in the chat box, name and enrollment number. आप chat box में लिख दीजिए अपना, जिन्होंने नहीं लिखा है, for attendance.
हाँ हाँ ठीक है, वो दे देता हूँ। ठीक है मैं दे देता हूँ।
मैम वो मेरिट की आप लिंक भी दे सकते हो वेबसाइट की, merit.ac.in।
merit.ac.in है।
ओके
या व्हाट्सएप कर दिया है ना?
ये मैं लिख रही हूँ चैट बॉक्स में, यही है बस।
ठीक है।
So सबने अपने अटेंडेंस डाल दिया है? Anybody is left?
यस मैम।
Please write your name and enrollment number in the chat box, please.
Thank you, ma'am.
Welcome. So we'll meet tomorrow. फिर ग्राफ थ्योरी के बारे में पढ़ेंगे। और कोई रहता है? Everybody is covered. Yes, Karan. Who is Karan?
जी मैम, मैं ये पूछ रहा था, मैं व्हाट्सएप ग्रुप में नहीं हूँ।
हाँ तो ज्वाइन कर लो ना, अभी चैट बॉक्स में एक लिंक दिया है ग्रुप का।
और मैम ये प्रैक्टिकल का कैसे पता लगेगा?
क्या
कोई इन्फॉर्मेशन नहीं आ रही मेरे पास।
किस चीज की? प्रैक्टिकल का क्या चीज? प्रैक्टिकल
ये
का
जो असाइनमेंट जमा करने हैं,
मतलब इसका इन्फॉर्मेशन क्या आना है? आपको पता है कि आप कौन से मोड के हो?
मैम मेरा मोड है।
MCA OL है कि ODL है?
2 मिनट मैम, मैं आपको बताता हूँ। ये मैम BCS L13 है।
BCSL?
जी
ये BCA, ये तो आप फर्स्ट सेमेस्टर MCA में क्यों ज्वाइन करके बैठे हो? आप तो BCA के स्टूडेंट हो।
जी जी।
तो आप कौन सा रीजनल सेंटर है? आप MCA में ज्वाइन करके बैठे हो। आपको सब्जेक्ट नहीं पता चल रहा है कि ये कौन सा सब्जेक्ट चल रहा है?
नो मैम, ऐसे पता नहीं लग रहा।
क्या क्यों नहीं पता चल रहा? आपने ये लिंक कहाँ से लिया?
ये लिंक तो जीमेल पे आया हुआ था।
ये लिंक कैसे जीमेल पे आया था? आप एमसीए फर्स्ट सेमेस्टर खोल के बैठ गए, आपको लिंक आया होगा कि मेरिट की वेबसाइट पे जाके आप बीसीए फर्स्ट सेमेस्टर का शेड्यूल देख लो, ऐसे आया है क्या आया है?
जी ऐसे ही आया है।
तो आप एमसीए क्यों फर्स्ट सेमेस्टर खोल के बैठ गए? बीसीए फर्स्ट सेमेस्टर का लिंक देखो ना। आप ओएल मोड के हो, ओडीएल मोड के हो?
मैम इस पे तो शो नहीं हो रहा।
क्या लिखा है आपका? बीसीए सिर्फ है, बीसीए ओएल है, क्या है
ये
प्रोग्राम, क्या
मैम
है? बीसीए है सिर्फ, बीसीए ओएल है?
बीसीए है मैम।
सिर्फ बीसीए है ना? कौन सा स्टडी सेंटर है?
ये है मॉल एजुकेशन।
हाँ तो मेरिट स्टडी सेंटर है, तो वहां चले जाओ, तुम्हारे बीसीए की क्लासेस स्टार्ट हो गई होंगी, वहां ऑफलाइन मोड में क्लास हो रही है बीसीए की।
ओके मैम ओके।
स्टडी सेंटर जाओ,
ओके
विजिट करो स्टडी सेंटर। और ये लिंक नहीं है तुम्हारा, ये एमसीए है, बीसीए नहीं है ये।
ओके।
हाँ जी, और किसी का कोई डाउट है?
मैम जिसका ओएल होगा उसको प्रोग्राम कोड में ओएल लिख के आएगा ना, एमसीए न्यू ओएल,
हाँ जी,
और नॉर्मल ओडीएल वालों को सिर्फ एमसीए न्यू लिख के आएगा।
एमसीए न्यू
ओके मैम।
सिर्फ। एनीथिंग एल्स? शुड वी एंड द क्लास?
नो मैम। ओके
Okay, then we'll meet tomorrow 10 a.m. आपकी क्लास है, then we'll go ahead with the next thing, right?
Thank you, ma'am.
Welcome, take care, and we'll meet tomorrow.
ओके मैम, थैंक यू।
Bye.
Thank you,
Thank you, ma'am.
Welcome, bye.